All right, good morning. So hopefully everybody has a good start about Lab 0 Part 1. Almost finishing, I hope. If you haven't, please catch up. It's actually so important. Normally for the lecture, I'll start with maybe some announcement just to remind you about what you should really pay attention to and what's really coming. We'll do that today. We haven't really covered much from last time, except for that clarification between runtime and compile time. I would also like to do some recap about what we covered in the last lecture usually. But today, it will be very brief. And then we'll move on to OOP review. I'll speak more about it. It's going to be quite a thorough review, but there will be also quite a bit of self-guided reading I'm going to assign to you as well. So please pay attention. Okay, let's now talk about some announcement. Okay, so last Wednesday's lecture about syllabus walkthrough, all the recording, the notes are already posted. Let me just remind you guys one more time, okay, just in case you're still a little bit confused, hopefully not. So that's a lecture site, and not e-class, but the lecture site. And you should really move on to about, so now we were in lecture 1 last time, so you can definitely look up the notes, etc. And for today, you can see the notes template for section B. You can click on this, and the clean version is already there. As I said, I'll try to make it available at least 1 hour before the class. You can always check, right? It may not bother you with the e-class announcement about this. Please just check, okay? All right, let's be back here. You guys' priority now should be, of course, Lab 0 Part 1. It is due tomorrow, I believe, right? I'll send you one more reminder tomorrow morning, and please make sure you submit in time. If you really haven't completed just yet, that's okay. Submit your best attempt. That's really the philosophy for the lab. I want you to make sure you're trying your best, but of course, before the actual test, you got to make sure you complete it and do the learning, okay? And your Lab 0 Part 2, basically to continue with the Lab 0, but Lab 0 Part 2 is going to be more challenging conceptually than Lab 0 Part 1. Because for Lab 0 Part 2, we're going to include the consideration of primitive array, which you will have to master by your programming test. All right, so that's something I want to give you a little bit of heads up. So please just get ready for Lab 0 Part 2. And for Wednesday, I think I will most likely try to do some live demo to really show you guys part of the OOP review, which we wouldn't be able to cover because when you talk about helper method, you really want to see how that works, you know, in terms of the benefits and how you can evolve from without any helper method to with helper method. You want to see that the evolution in Eclipse. We don't really have the time luxury during the lecture, but I would like to do that maybe in the lab session. I will do in one of the lab sessions. I haven't really chosen which one because I also need to attend for the lab session for the other course, but I'll let you guys know. But you can expect that this Wednesday, I will be in one of the lab sessions to really give you some demo. So you can go there and then enjoy. I think it's going to be beneficial. I'll keep you posted. And it is very important for now for you to look at the course calendar to see what we are expecting, right? Let's now remind all of us quickly. All right, so we are now here on the 8th of September, right? So please make sure you know about the deadline for Lab 0 Part 1 tomorrow and also release Part 2. So next Wednesday, which will be the 17th, I would like to give you guys some mock-up test for Programming Test 0. That one there is optional attendance, but I'll really encourage you to come. If you want to come for 2 sessions for the mock-up test, no problem. We should have enough space. Normally, your fellow student wouldn't want to come if that's optional, right? But, you know, take advantage. And basically, I'm going to boost the machine into the Linux mode, lab test mode. You can try it out the practice test, just like the real test. It's only going to run for 40 minutes, right? Just for you to get a feel. I'll also give you the solution, the question for the practice test afterwards, and I'll also give you some instruction about how you can simulate the mock-up test over the remote lab. So you definitely got lots of chances to practice on your own as well. But, you know, why not come to the lab and also get some idea. The real thing is going to come the week after, right? So you really want to make sure you get prepared for September 24th. All right, so that's the real thing. But, you know, that one's 2% just to get you, you know, going, you know, for the course, get a feel. All right, any question so far? All right, your priority now, Lab 0, Part 1 and Part 2, right? Once Part 2 is released, I will encourage you to really start and complete it as soon as you can. All right. All right, if no further questions, I just want to recap very briefly about this diagram over here, which we spoke about last time. It is so important for you to have a clear separation between compile time and also runtime. Compile time is when you're writing the Java code in the Eclipse editor. As soon as you hit save, it's going to somehow compile your code to see if there's any either syntax error, which we spoke about last time, or type errors, right? You can review the differences. And we definitely see lots of type errors that you may have to want to pay attention to. That's something I also need to talk about when we cover different aspects for the course, okay? And for the runtime, you want to be sure you actually try to be away from these kind of classic exception. I'll talk more about null pointer exception a little bit more, today. I'm pretty sure you have maybe experienced that in the first year. But the point number 2 is really something, not much to say, usually on the paper, because this kind of creative error is really going to happen when you actually got some logical error. You're supposed to program for output X, but your program return output Y, and they are not the same, right? So it's a very general general account about this kind of error, but you just want to watch out for that. I mean, that's really why you're coming to lectures for. I'll always try to remind you about what should be the reasoning and what should be the logical account behind the programs. That's something we want to focus on as well for this course. All right, not much to say, but please go over this diagram here and make sure you are kind of convinced about the flow, about different errors you have. Compile error versus runtime error. If you got any issue you want to be clarified, let me know as well. And I do have my office hour starting today. It will be 6 p.m. If you want to speak to me in person, you're more than welcome to. Okay. All right, let's now start with the lecture. Okay. So on the lecture side, I already got a slides posted, right? So you can see the classes and objects. So this slide here, you will see that there are quite many slides there, but there'll be quite a bit of slides I want to assign to you for self-guided reading as well. I'll let you know exactly what you should do as we go. But that one, don't wait for me in the lecture. I'm going to highlight this challenging stuff that you should really know, and we'll discuss them in the lecture as well. But you definitely want to also study on your own as well, the slides. Read it more like a textbook and take notes, okay? And there is one section here about exercises. What I posted right now is something here, okay? I will actually walk over with you about this exercise in about 1 or 2 lectures time. Not very likely to be this week, but maybe more likely next Monday. However, I will encourage you to really try this one here on your own. Right? So this one here, maybe after you have gone through Lab 0 Part 2 or part of it, or if you're already very confident about manipulating primitive array in Java, I would say give a try on this one about tracing. So this will give you some very good example about what you can expect roughly as one typical question in the written test, and definitely on the exam. Right? Give a try, and then we'll talk about the solution. We'll go over that, and also visualize the code, most likely next Monday, if not this Wednesday. Okay, let's now go over some slides. There we go. Okay. All right, so that's the tutorial series you're required to study for your Lab 0 Part 1 and Part 2, right? So once you finish Part 1, just go over the other part about using primitive array. And then this slide here is optional tutorial, which I also mentioned to you guys on day 1. All right. And when you actually look at this particular tutorial series, and you may want to pay more attention to, of course, just about using Eclipse if you're not used to it. And you want to learn about debugger, right? I cannot emphasize more. Debugger is really a must for you to really find issues in your code. You don't just want to use system.out.println to find errors. That's not a way to go in the long term, all right? Debugger. And of course, the TA, or sometimes myself, will be in the lab session, usually for Q&A. So you can also ask the TA how to use debugger, right? That's also a very nice way to use the resources. Okay? Or you can just come to my office hour. I'll be more than happy to show you how to use debugger. And things like conditionals and also arrays, loops, especially I think these topics over here just about how you can use the debugger to see the details about using conditional arrays and loops, right? That's a very nice way to practice about debugger. I'll leave the exercise to you. All right, and that's right. So this slide here just about something optional. If you really want to do some extra study to catch up with your background, feel free. All right, I want to emphasize one more time, these 2 notes are required. The number 1 here is about how you can figure out the Java code to write based on JUnit test cases. You want to figure out what classes to create, what constructor to define, and also whether it should be accessor or mutator to define, and then the logic of the method, right? You want to read this note at least to get an idea about the formats. And this will be the format for all your subsequent programming tests throughout the semester, right? So you want to be very careful about understanding this. The second one here will be a very nice supplement to your Lab 0 Part 2. So Lab 0 Part 2, as I said, is going to talk about how you can integrate primitive arrays into Java classes, right? If you declare some attributes rather than of type integer string, they're like a simple type. But now if you declare primitive array as a type, let's say an array of person or an array of integer, things like that, how can you manipulate it? So this note here actually supplements very well about Lab 0 Part 2. So if you study these two resources together, that should really give you very good ground for programming test 0. All right? All right, guys, again, I cannot emphasize more. These two notes are so crucial for you to go over. All right, so please do form a study group if you want to. Ask me questions on the notes. All right, learning outcomes. So for this review lecture, you can see we got about close to 90 slides. So I may not read out the slides too much in the lecture. I plan to cover the review stuff, including today, maybe 4 lectures. That's my goal before we move on to exceptions. But I think 4 lectures should be enough. So I may not cover every bullet point, but there will be some reading you really have to do on your own. Okay. What are we going to review? Object orientation, which I just want to talk more from the philosophical point of view and exactly how you're supposed to use object orientation, which doesn't really exist in procedural language like a C or maybe assembly, right? So for those of you who might be taking 2031 for C or 2021 for MISP, I presume, right? Assembly language, they don't really support object orientation. So, but object orientation is very, very powerful if you want to program big, if you want to program something substantial. It's really the way to go. All right, we're going to review classes, objects, and also the use of this keyword, right? You may have used this keyword, but maybe in the very elementary level in the first year, but that's okay. But we're going to see the more advanced usage in the review and also later on as well. The this keyword is definitely powerful that we need to understand. And also how to create instances. Maybe not today, but on Wednesday, I'm also going to show you how you can create some visualization on the paper to help you trace the code. It's also a very important technique I want you to pick up from this course. We will never actually grade any diagrams you draw to actually trace the code. So usually in the written test or in the exam, if we ask you to trace the code, we are only interested in the outcome of the program, usually. But to really get the outcome, you have to be able to work out the exact derivations, for the tracing. So the visualization technique I'm going to show to you, which I will make sure I introduce to you properly on Wednesday, is going to be very useful. Simple, intuitive, and also very useful. We'll get lots of chances to practice throughout the term. All right, so this one here just about reference type attributes, right? We'll talk about data types today as well, but we definitely dive more into it as we go throughout the semester. Whenever you want to have attributes, either single value, let's say a single integer, right? As opposed to integer square brackets, like a primitive array, right? That's kind of the visualization you want to have in your mind as well. If you haven't got it yet, that's okay. I'll show you how you can have a useful visualization for this course. And we're also going to cover something about static, right? Static, either static versus non-static. But that one will come maybe a little bit towards the end in the review. Okay. Helper methods. So that one, the slide is already there, but I plan to cover this more effectively maybe in the lab session. So I'll do some demo together with you. You can also ask me questions. I'll try to see if I can record the session as well. But it works maybe the best. Just come to the live session and ask questions. Okay, the first here, just to clarify the context, separation of concern. Okay, so you guys took 1022, and your fellow student from section G mostly took 1021, but more or less the same, the same similar learning outcomes. So here is something I want you guys to remember. I'll show you the diagram also as well. Whenever you're programming, right, you should really want to think about there's different components of your software projects. There's not a single component you're going to program. That's too big. You want to separate your mind to different aspects, right? So there are three components I want you to separate between. One is about the model components. Whenever I talk about model, this is really where the logic, where the value is, where you put your creativity into, right? That's really something you want to focus on creating. In the programming test, this model components or model package is where you're going to develop things from scratch. Okay, model component. And usually it can be one single Java class or multiple Java classes, most likely, for your labs and also for your programming test. And we got also something called controller or tester. Okay, controller, well, think about controller and tester, they're simply using whatever you develop in the model package, right? If I develop a person class, I want to call methods and create instances of person class. So controller and also something called tester is something that we want to really make use of whatever we have developed. Great, let's visualize it quickly, right? Of course, you can read the details in the bullet points. So in your lab 0 part 1, I believe I also kind of show you this similar diagram, or maybe the same diagram, right? Also similar architecture. To begin with, you are discouraged to think about console application, which is about system.out.println. Very occasionally, maybe some of the example I put on the lectures, I might still use system.out.println just for quick, illustration. But for you, for the labs and for the programming test, you shouldn't really have to touch any system.out.println. Okay? So this part here is really forbidden. It's just about printing something to the console or reading something from the keyboard. That's not something we do in this course. It's too low level. We want to do something more rigorous. Okay? This will be discouraged. Not strictly forbidden, you can still do it if you want to, but I will encourage you to really stay away from that. It will be better for your learning. So what you really want to focus on will be two components. One will be the model, and the other one will be the JUnit tests package, right? So these are the typical two packages you will have to develop for your lab and also for your programming test. But usually this part here will be given to you. This one specifies what you are supposed to develop. Okay, so this part here, JUnit test, you can think about this part here really tells you the specification. It's more about what you're supposed to develop for your projects. You'll be given maybe a single so-called starter test, JUnit class. From there, you got lots of different methods for testing what you're supposed to do. And we'll talk more about JUnit assertions maybe in the later lecture, but I think Lab 0, Part 1 and Part 2 should really give you enough background about the assertion you should know. And just notice that the way we put the specification is by telling you what's the expected value you're supposed to get. And you will see exactly what I mean as you complete Lab 0, Part 1 and Part 2. All right, so that's about JUnit test package. The model part is really the gold for your software, right? That's something, of course, between different programming tests and between different labs, you just got different model classes to develop, right? You will see lots of different variants, which you will see throughout this course. So the way I will conceive about model here is it's just about the logic of your implementation. The logic of your implementation. Okay, the logic. Of course, if you try to program with certain logic, your logic could be wrong, could be right? It depends, right? So that's why we also got runtime errors, which is quite typical, right? Whenever you want to develop something. Of course, in the model here, you got classes, you got methods, and for the methods, you got different kinds here as well. That's also something we'll review as we go over the lecture, right? But separation concern, you got model here, you got testing over here. And notice that. Think about each test here is really trying to use whatever you're developing over here, right? Think about the use over here, right? It's a very important relation. Another way to think about it intuitively, which we'll also try to introduce you again once we talk about exception. Think about the model classes you're developing is more like a supplier. So the model you're developing is more like a supplier. You are supplying something potentially useful for somebody else. The JUnit test is really what I call a client. Client is one of the users who's trying to use whatever you have developed. So the user or the client is telling you, this is how I want your Java code to work like. And your goal is to make sure you satisfy what the client tells you to do. All right? So that's kind of the intuitive connection between these two packages. All right? All right, any questions? Yes?
Would we say that the JUnit tests are controllers in this case?
I wouldn't say JUnit tests are controller. Controller usually means you want to print out something to the console or take something from the keyboard. So I would say JUnit tests, they're quite silent. They basically just take some return value from the method or pass some input value to the method. I wouldn't say a controller. Yeah, yes. I would know what you mean, but just being a little bit stricter, right? Yeah, good. I think your fellow student asked a very good questions. So JUnit test over here, I wouldn't call it a controller, okay? Controller usually will be something tangible or something visible you will see, right? So it could be a controller for controlling the traffic lights, in which case you can see that visually, right? Or it can be a controller for controlling the pacemaker, for human heart. That's also something tangible. But for JUnit test, you don't really see anything tangible, except it's either green or red at the end, right? Okay, good. Yeah, so please go over the different bullet points, right? It's not really worth our time to read over all the bullet points, but please fill out the gap. I just want to highlight the stuff to you, so you can also do some self-study on your own, okay? All right, so that's good. Let's now move on. Okay. Yeah, so in Java, we may define one or more classes and also define one or more methods, right? That's really the fun at the same time challenge for OOP. That's something we'll see throughout the course. Okay. All right, so this will be something I would like to, maybe either review or clarify just about how the object orientation, this set programming paradigm, it will work. The object orientation doesn't exist in assembly. It doesn't exist in C, right? So these are the two very mainstream languages you may have to work in. But for Java, Python, or C# or C++, I think you have to know about object orientation. I want to just talk about the philosophy about object orientation. And then we'll do a little bit more Java-like, Java-specific stuff after that. Okay. So there is one diagram I want you to be aware. Okay, that's kind of small. You can also feel free to download a copy of the diagram. If you go to the lecture site, you will see that it's right here. Okay, the observe, model, execute process. Okay, you can feel free to print a copy or download to your tablet computer, right? It's quite a nice diagram to show you the different flow. And this one here nicely corresponds to compile time versus runtime, right? Just different angle to see these two phenomena, really. Okay, let's take a look. All right, so observe, model, execute. Okay, I'm going to annotate on my iPad, but for those of you who want to just dive a little bit more into more examples, you can also feel free. There's one link for the tutorial video, about half an hour, I guess. I didn't check it, but that's also nice for you to also take a look, just in case you want to. Otherwise, I think following what I'm going to say right now should be okay. All right, let's now take a look. Okay. Let's now start with the first stage of the process, which is called observe. Observe simply means I'm really observing as an engineer. I'm observing either a scientist or an engineer. I'm observing the real world surrounding me for the problem I want to solve. Maybe I want to solve some problems about calculating the BMI, body mass index, for different people, right? So what I'm doing is I'm observing. I'm observing that I got two people around me, let's say my friends. Let's say I got Jim, I got Jonathan, let's say. So Jim here, also Jonathan here, right? So Jim and Jonathan, you can think about these are just names to identify different entities or different persons, right, in the real world. I start with this observation here, and then I'll try to somehow classify about entities of the same kind. What do I mean? So first of all, I'll start with entities. Entities is a very general term. anything you can see tangible, or either tangible or intangible. You can think about that as entity. It could be an Apple Pencil, could be my Mac, could be a projector, could be your hat, whatever, right? Anything you can see, you can observe. It's called entities. In this case, the entities we are observing from Jim and Jonathan, they are entities of the same kind. Let's call them persons. All right? So now for the person kind of entities, we try to observe different attributes, like each entity will share, right? We want to identify what's the common thing they're kind of sharing for the same entities. Of course, let's say we got another kind of entity. Let's say I got also in the two-dimensional plane, I also got 2 and 3. I also maybe got -4, -6, let's say, right? If I want to program eventually, I wouldn't really consider Jonathan and 2, 3 as the same kind of entity for sure, right? So what I should really consider is these two as the same entity, and these two also as the same kind of entity, and model them separately. Okay, so in the lecture, I will do this one here only, but you will see that in the lecture example, we also do this one as well. You can also try to practice by figuring out what should be the different questions you want to answer when you do the modeling. Right, let's talk about these two, okay, these two entities. So at the entities we have here is Jim and Jonathan, of course. And since we eventually want to calculate the body mass index, right? So we should really somehow observe the relevant attributes. Of course, for each entity, there are so many attributes that you can actually observe. You only observe and record the relevant ones. Relevant in the sense that you want to know eventually what you really want to solve, right? What kind of app or what kind of application you want to develop. So here, attributes could be, I want to observe maybe their weight and height. So for example, maybe Jonathan is slightly heavier, and also Jim is taller, things like that, right? So attributes here will be, I can say they got the weights and also heights. There will be something I will write also separately on the iPad as well a little bit later, but notice one thing here. This is very important. Every entity of the same kind, they share some common set of attributes. What does that mean? That means Jim has weight and height. Jonathan, the same kind of entity, also has weight and height. Number one. Number two, individual entities of the same kind, even though they share the same set of attributes, but their attribute values might be different. For example, let's say as far as height is concerned, Jim's height will be larger than Jonathan's height, even though they both have heights. The values might be different. We call them instance-specific attribute values. That's something I'll write down in a moment, all right? And also changes in inquiry. So these are the things you can actually do to the individual entities. Changes means you want to modify the attribute value. So changes could be, maybe you want to say, maybe they might get taller, grow taller. Typically, for the name of the method in Java, you have to indicate about what exactly the change should be, right? So here, just say grow taller. So maybe increasing the heights for the entity, right? Inquiries will be you want to ask some question about the entity without changing their attribute values. Could be I want to get their weights. Also, I want to get their BMI calculation. So these are all the kind of observations you should really make informally. Once you have made these observations, now you can think about if I want to put all my observation into programming, into something that can work. Now I should really start thinking about how I can somehow extract all the commonalities among these entities, like a Jim and Jonathan. So that's why you will see something called template. Template is something that you can instantiate for as many times as you like. Of course, we call template here. Informally, in Java, template is like a class, okay? So we just call person. Think about Jim is one instantiation of the person template. And Jonathan is just another instantiation of the person template. I'll also visualize that in one moment. So you can think about the template definition is really the outcome from the observe stage. Once you got the template definition, you can move on to the model stage in Java. All right. Okay, so we got, okay, let's see what we got. From stage number 1, we got entities over here. We got Jim and Jonathan, right? So now what we do is in stage number 2, we will try to model in Java, okay? So when we try to model, so that'll be stage number 2, model. So model here, just in Java, okay? So that's a model stage. You can see out of Jim and Jonathan, we make a common template for them called person, right? That's a template. Think about this one here is the template, or class, of course. And the different attributes that all the entities will share are, the usual syntax you're used to, right? For example, you got name, you got weight, you got height. So these are the attributes. And notice that this is the template for these entities. On the other hand, if I define another template here called points, it does not apply to these two, right? Apparently, right? So this template here only applies to these two entities. Question?
You mentioned about instance-specific attributes. Was it?
I'll get to it, yeah. So if Alice here was asking about instance-specific attribute value, well, I'll get there. Actually, I definitely want to elaborate on that. But let me just finish this flow here, and I will elaborate. Very good, okay. All right, so that's about at a Java level, at a compilation level. So think about this part here is really about compilation. Okay, so this part here is really about compile time. So assuming that your definition for the class or the template has no syntax or type error, you can move on to the runtime. Okay, so that'll be the final stage, which I call execute. We are actually going to run the code. And there are several ingredients for executing the code. Well, I'll write it down. So when you get to the execute, right, there's a big assumption. Assume everything compiles. There should be no compilation error from the compile time. Even with a single error for compilation, you cannot really execute the code fully. So that's why it is so important for you to make sure there's no compilation error when you submit your programming test, right? Everything compiles. Given that everything compiles, what can we do typically? Okay, I'll just make it a little bit simple, just to start with. Number 1, you can create instances or create objects. There are 2 ways to put it. You can either say you can instantiate templates, or you can say you're trying to create objects. They really mean the same thing. Of course, create object is more OOP kind of oriented, right? And once you have created all the instantiations or all the objects, you can invoke methods on the objects, right? Number 3 is you can invoke methods on objects. Of course, here I'm being very simple. I'll elaborate also later exactly how you can trace the method call invocation. That's something we gotta dive into as well. Okay, one more point. Of course, you cannot expect everything to work off the bat. You cannot expect that in general. So number 4 is also very important. You have to somehow test and debug your code. You have to write some JUnit assertion. Luckily, most of them will be given to you during the lab or during the programming test. But I would say it doesn't hurt for you to practice how to write some JUnit assertion as well. They're quite easy to write. You will see lots of examples. You can just copy and paste and do some slight modification. You want to test your runtime using some JUnit test cases. And also, whenever you run into any issue, what should you do? Debugger. All right, so test and debug. So test and debug. All right, so we talk about 4 things that really happen at a runtime. We assume there's no compilation error. And also, we may instantiate as many objects as we like from different classes. And we may actually invoke different methods. Maybe, you can think about constructors. It's like a method as well. But we just say, creating objects like a constructor's job. You can call mutator. You can call accessor, different methods. And also, you want to make sure you test and debug your code before you can get to the final stage when you are confident to release your projects, release your code. Okay, let me just show more correspondence, and then I do want to just do a little bit more illustration, some notes for you. Okay, so you can see that here we got person as a template here, right? Each person can be instantiated at a runtime for as many times as you like. Okay, so you can think about this is one instantiation. This is just another instantiation. All right, and then let's visualize this very carefully. This is one instantiation. This is one object. This is another object. For now, we know that this object here is called Jin, and this object here is called Jonathan. They are different objects, but they are instantiated from the same template. They are actually instantiated from the same class. And by the way, so this is the kind of diagram that we will have to learn how to draw, which is not difficult. I'll show you exactly how you can draw that, possibly on Wednesday, more thoroughly. And let's now talk about instance specific, also instance. Let's talk about things that are instance specific and also things that are not instance specific. Start with this. If you look at name, heights, weights. Name, weights, and heights. So these are the common attributes every instance of the same kind share. These are the attributes shared by all person objects. So every person object has the name, weight, and heights. However, instance specific. Specific to this particular instance, the name value may be Jin. Specific to this instance here, the name may be Jonathan. So that's what I meant by instance specific value. All right, so you can see that. You have, for example, here, Jin versus Jonathan. 1.8, 1 versus 1.8. Even though they're the same value, that's okay. It doesn't have to be. Right? In real life, you may have two persons with the same weight and the same height. That's okay. Right? So attribute values may or may not be different, but the attribute names must be the same among the objects of the same kind. Guys, any question so far? All right. It's a very quick overview about the different stages for you, but luckily for this course, mostly you don't have to do too many observations. The observations usually are just summarized as a certain description and given to you, so you don't have to do too much about this. If you want to do more, maybe in 3311, software design, or maybe even later, 4312, software engineering requirements. If there's some course you are interested, you may learn about it. But for this course, we don't touch much about this part here. For this course, it's really about implementing in Java classes and see how you can do it at a runtime in a disciplined way. Okay. All right, so for this part here, I'll let you do an exercise, but I'd like to talk a little bit more about the comparison. Okay. Let's now try to draw the boundary between the two worlds. We got object orientation, OO. Also, we got object-oriented programming as well. Object-oriented programming can be Java, for example. I think C#. I'll just give two examples. There are many other things. Right? I believe in Python, they also support some object orientation as well. So you can definitely put it into this category. Right? Okay, so object orientation. So we talk about templates. And we talk about instances. And you may, for individual instances, you may change their attribute values. You may make some inquiries about the different attribute values, right? What's the correspondence? So for templates in Java, you just classes. And for instances, it will be objects. And for changes, it's something called mutators or setters. And what's so special about this kind of method is they have no return type, just void. For example, you might say void, which is a keyword in Java. You can say set the heights to be certain value. Okay, dot dot just means I omit the details, right? So void here is really important for modeling some changes, just void. And inquiries will be something called accessors or scatters. Okay, so for example, it could be I want to get a name of the person, in which case I'll return some string. I may want to get the weights of the person, in which case I might return a double. Right? Things like that. It's just not void. So these two are simply not void. All right? Just some simple table just for you to show you the correspondence. And let me do another one here. Okay. Just give me one moment. Okay. So this one, let me just also summarize about what I said here, just to remind you. So here we say entities of the same kind share the same set of attributes. I'll give you examples in just one moment. Let me write down the two principles. That's number one. Number two, values of attribute among entities of the same kind may have different values. Values of attributes among entities of the same kind. May be different, may or may not be the same, so they may be different. Okay, let's see some example right away, which we went through. Entities of the same kind. Okay, for example, Jonathan and Jim. And what kind? That's a template name, person. Right? Share the same set of attributes. Both of them has the weights and heights. All right? And then we say values of attributes, right? So here, Jim may have different weights than the weights for Jonathan, right? So values of attributes over here, you can think about, so Jim dot, right? So dot notation is also something we're gonna review. Give me one moment, let me finish this, I'll get to you. So we might say Jim dot weights versus Jonathan dot weights. May or may not be the same. Question, please.
If you have a class and it has like two different constructors that take in two different pieces of information, how would the entities of the same kind work with having the same attributes?
So, okay, I see what you mean. Let's say we got a person, right? Let's say we just got weight and heights. So we got double here, double weights, and also double heights. Let's say we got two attributes. So let's say we got two constructors here. Of course, usually for constructor, it must be public. For now, I just omit the public, just make it simpler. Okay. So we may have one constructor here, So maybe that one there, we are only trying to initialize the weights. And then we put some relevant information. Okay, we can fill in the detail later. Okay, and we got another constructor, let's say. So person double, and that one there is going to initialize the heights. So we got two constructors over here, right? Let's see exactly how using two different constructors are going to create objects of the same kind, right? Maybe that's what you were confused about. Let's take a look. Okay. So that's kind of the definition for the Java class, and I will also encourage you guys to also give a try on this one here on the Eclipse to see how that works, right? So once you define the class, let's now take a look at some tester, okay? I can say, let's say person, let's say Jin. One thing to actually note right away, actually. Okay, for this one here, would this even compile though in Java? It's a little review question for you guys. Intuitively, you might be thinking it should compile because I got weight here, I got height here, right? I'm giving different names for the input. Would it compile? If I write something like this, new person, and then I simply say, let's say 72.6 kilograms, let's say. Now, do I have any issue here? When Java runtime sees this line here, you're calling the constructor with 72.6, a double value. Look back. It's ambiguous. We don't really know whether it's this one being called for the weights or this one here being called for the heights. So there is a rule. Whenever you want to define methods or constructor of the same name, you have to make sure the list of types in the input here or parameters must be distinct. Otherwise, you run into issues. That's something aside, okay? Here, this will give you some compilation error. Because the list of, I'll write parameter for now because we still got to clarify exactly the difference between parameter and argument. I'll do that either today or maybe next time, okay? The list of parameter types is not distinct. It's not. This one here takes exactly one double. This one takes another double, right? You can think about conceptually, for this one here, it takes one list, just double. And this one here takes another list, which is double. If you compare these two lists, they are not the same. Sorry, they are simply not the same, so it got error. Okay, how can we fix this, right? Either you can change one of them to be integer. That might fix the error, so they got different types. Or you can introduce maybe an additional parameter over here. You can say, for example, whenever I want to initialize the weights of a person, I will also initialize their name or height at the same time. Something like that, right? So you can be a little bit more creative. So what I would do is, let me just say for now, I can either, so this, I'll just create different pages. So this one will give you error, right? And then I'll create another page. Ambiguous. Which version to call? Right, so give a try on this particular setup for the person constructor and see how you get a compilation error. Right, so this will give you that. On the other hand, let me give you a fixed version, and then I'll also get back to the original question. So guys, what I'm talking about here, even though it's kind of triggered by your fellow students' question, they're all relevant. All right, so make sure you kind of also study them as well. Okay. Okay, so this is the one that has the error. How do we fix it? Okay, the way to fix it goes like this. I'm just going to maybe remove the stuff that's not relevant anymore. Okay, let's now fix this. So we still got this class over here. I'm just going to maybe modify this version here rather than double weights. Okay? Let's say whenever I want to create a person object, I can choose to either pass the height alone, or I have to pass both their name or their weight and height together, let's say. Okay? I can make the rules myself. So this one here, I can say double weights, comma, double heights. So now what are the two lists look like? So now you can think about this particular one. The list will look like double and double. And this one here, on the other hand, has only one single double. There will be no ambiguity. Whenever I pass only a single double, I know that it should be one for heights, one for weights. If I pass only one double, it should be only for the heights, right? Okay, so let's now think about this part here. If I say Jim here, so you can see here, 72.6. Let me change the value. That might be a little bit too short. Okay. Let's say, I don't know, in centimeters. Let's say in centimeters. Let's say maybe 173. I don't know, something like that. Right? You can see 173.2. So this one here should match this one here, right? On the other hand, I can have another object instantiation. I can say person Jonathan will be new person. And then I should really pass both the weights and the heights. So weights could be maybe 84.5 kilograms, maybe 185.7 centimeters. Right, so now I'm calling two different constructors, right? So let's see how these two constructors are going to create entities of the same kind. However, for those two entities, their attribute value might be different, right? That's really, I believe what the question was. Let's call this one here number 1, and here number 2, okay? I wouldn't go into the tracing in very much detail. That's something we should do on Wednesday, but let's just do that very quickly. From number 1, I'm basically creating an object of type person. So I'll just put a person here. How do I know it's a person? Right here, that's a type, right? I put person over here. I know that according to the definition for person, I got weights and heights. I got weights, I got heights. And I know that the name of the object should be Jin. Okay, I'll talk about what error really means next time, but for now, just take it for granted, okay? And for this particular person, we know that this 173.2 must be for the heights, right? So I'll put 173.2. And for the constructor, anything you don't really pass, you may just want to get a default value for now, which could be maybe just 0 for the weights, maybe. Okay, you can set a weight maybe later. And for number 2, okay, I'm creating another person object, right? You can see it's really a box, just a chunk of memory. And I'm still putting person. Notice that the person here really corresponds to the type. You can see person here, person here, person here, and person here, right? There's a correspondence here. Person, and also it has also the weights and the heights as well. So we got the weights and the heights. But this time we're calling 84, we're calling two numbers. So one will be for weights, the other one for heights, right? So we got 84.5, 185.7, right? And this one here is Jonathan. So now if you compare these two boxes, this is an object of type person. This is another object of type person. They're different objects. Two different instances, two different entities of the same kind. However, the way we have created them will make the values of their attributes different, right? It's a very long answer to your original question, but that kind of makes sense. Okay, yeah. Of course, this will be something you have to also make sure you kind of understand, about how you can create different objects of the same kind, and also try to visualize about what the attribute values are. That's something we also try to review as well. All right, any questions? Okay, good. So guys, how about this? We got about 25 minutes. Why don't we take a very short break, and we should do some trial attendance check for today, right? And then give it a try, okay? So why don't you get your iClicker ready, and let's give it a try. All right, so let's continue. I do want to go over a bit more basic concept today. We'll do a little bit of tracing. We'll do much of the tracing maybe on Wednesday and next week. Got about 18 minutes. Let's see how far we can go. Before that, I just want to write down something. This will be some reading I would like you guys to go over on the slides. They are rather straightforward. We don't need to go over them in class per se. Okay, I'll write down for you. Okay, you can see we are now right here before the break. After that, slide number 7 about that observe, model, execute process, starting from slide number 8. That's something I will talk about, but I want you to do a little bit of study here. Okay, so slide 9. 9 to 47. They are not very technical, but they are just clarifying some concept, which we also kind of talk about, right? Just also about how you can identify different nouns and verbs for Java method, etc. That's pretty easy for you to go over. Assign readings, all right? Of course, if you run into any difficulties about those, reach out to me. More than happy to clarify. Okay, I'll leave them to you. For now, I do want to talk about some stuff I think that'll be worth our attention. Okay, let's go over one by one. I want to start with this one here. This is just a list about the different ingredients for OOP. And I want to highlight just 2 parts over here. So one is something called refactoring. Okay, you may have seen this word maybe somewhere. Refactoring is actually a very common term you have to understand for software engineering or software developments. What does refactoring really mean? Okay, I'll write down some definition here. Whenever you say, I want to do some refactoring of my code or my projects, that means I want to modify the internal, the private stuff, the internal workings. Or you can think about internal simply means private. Could be private attributes or could be private methods. Private simply means nobody else except you as the developer for the class would know about it, right? So anybody else except you, who are the developer, will be aware, okay, about the internal workings. So you only modify the internal workings without any public or external users realizing it. Let's say, for example, I am developing some person class, okay? And then you are the client, you are the user of my class, right? If I say I'm doing refactoring now, I'm saying maybe I find that the way I calculate BMI was not exactly efficient. I want to just change the way I calculate BMI. But as far as you as an external user is concerned, the result you get will still be correct. It's just that I changed the way I calculate. But do you really care? Not really, because just the way I calculate is a bit more efficient. But from your point of view, you're still getting the same result, just the same. But this might sound a little bit abstract, that's okay. So this is to do with something about helper methods, which I would like to demonstrate on Wednesday to you, okay? So, helper methods. One way to do refactoring at this level would be helper methods. So I think since you're also going to do lab number 1 also very soon, so I think maybe go over with you about helper method will be also very useful. So let's do that on Wednesday. But I'll let you know which lab session I will show up. Okay, I'll let you know exactly. Okay, and I'll give you more details about this helper method. Another thing I want to draw your attention is something about the dot notation. Okay, so this is something we also have to be very careful. The one very special feature about OOP is you can actually navigate between different classes or between different objects. So you might have, for example, obj number 1 Let's say there's an object creates. You can say obj1.m1. That might be most likely the format you're used to from the first year. But in this course, you may want to say obj.m1 and then .m2 and then .m3. It's called a method call chain. It is also very common in OOP. This is called a chain of method call. This is something we also need to be aware, also master as well. Okay, that's something we'll definitely do. Lots of examples for later. And for the rest of the list, please go over just about different definition. For example, what's really constructor, what's the accessor, getter, mutator, etc. Right? That's something you can go over. Right? Good. And then let's now go over some stuff here. Okay. Okay, let me show you a little bit more, some conceptual stuff here. Okay. All right. Let's go back to our Jim and Jonathan example. Okay. Let's see some Java code. Let's say we got a person here and Jim is assigned to something. Right? You can think about on the right-hand side, the ... is more like a new keyword calling the constructor. Let's omit the detail. Let's say I successfully create Jim. And also I got a person here. Let's say John. Okay. Basically, I got two objects. All right. And I may have some Java code here, which will set up Jim and Jonathan, right? Just about their weights and heights, let's say. And now I'm going to display 6 lines of code. And let's discuss conceptually about how we can compare them. I think that can also strengthen our understanding about instance-specific attribute value, what I was thinking about. All right. So line number 1, I might say at some point I say Jim dot get weight. Okay. And then I may return something from there. Okay, and then number 2, I might say John dot get weight. How about this? I'll write all the 6 lines first, and then we'll compare them. And then I might say Jim dot gain weights by 2 kilograms. Number 4, I might say John dot gain weights, also 2 kilograms. And let me be a little bit lazy. Okay, another 2 lines. Number 5, number 6. 6 lines. So roughly, can you kind of see what I'm doing here? I'm trying to manipulate. I'm trying to create 2 objects here, Jim and Jonathan. I'm trying to manipulate them in different scenarios. All right, so let's do different comparison. Let's start from number 1. If I compare number 1 versus number 2, you can see for number 1 and number 2, I'm basically calling the same method. The same method. In this case, they don't take any input value. I just want to get the weights. Now, question is, I'm calling the same method. Are they going to give me the same result? Not necessarily. They could give me the same result if the 2 person have the same weights, yes, but not necessarily in general. All right? It really depends on the context objects. So that's something I want to highlight. So Jim and John over here. So to the left of the dot, we got Jim and Jonathan. So this is what we call context objects. So the values that we're going to get from this call and this call here really depends on what the context objects are. If they have the same weights, sure. If they don't have the same weights, then it's not the same. Let's say for now, this one here may just return 72. And this one here returns 85. Let's say they're different. All right? Okay, let's continue. So the first comparison we just made is 1 versus 2. Let's do another one, let's say 3 versus 4. All right, so now let's think about it. So now for 3 versus 4, again, we're calling the same method here. And the same method here. Not only that we're calling the same method called gain weights, but also the same input value. So both of them are gaining by 2 kilograms. Now, are these two lines going to give us the same effects? The answer should be no, because this one here applies the 2 kilograms increase to Jin. This one here applies the 2 kilograms increase to John. Jim and John may not be the same objects. They might be, though, if they point to the same objects, which is something called aliasing. That's something we'll talk about. Okay? Again, it depends on the context objects. All right? So you can think about this one here is like a +2 to Jim's weights. And this one here is +2 to Jonathan's weights. So the +2 part is the same. It's the same method definition. But when you apply the same method definition to different objects, you may have different effects. Right? That's also something very important. And one thing to say here, I want to also give you a little bit heads up for later. Jim and Jonathan here, they may refer to the same objects. And put a star here. And the star I talk about is something called reference aliasing. Meaning that you got different variable names, but they really store the same address. That's something we'll also review next on Wednesday. All right. So finally, you can see if I say here again, get weights and get weights, right? Even though I'm still calling the same, oh, here it's a bit different. So now we got 1 versus 2, 3 versus 4. So now I want to compare 1 versus 5. All right. This is also very important. Now let's see this. 1 and 5. All right. Oh, you know what? For this one here, just make sure it'll be more readable to you later. Oh. Okay. Okay, 1 and 5. 1 and 5. Compare these two. If you look at these two lines, they look exactly the same. The context objects are the same. The method being called, also the same. Agree? We got identical two lines. Am I supposed to get the same result? Ah, good. How come? Tell me a line number. That's the reason. 4? 3. Good. Exactly. So OOP is very context dependent. Even though I'm calling just the same line, but because of 3 here, it makes a difference. Okay? So here, apparently, it's going to be 74, I believe. Okay? Okay, so this will be not the same. Because 3. Okay, I'll write down another one there just for your information. If you compare 2 versus 6, right? 2 versus 6, now we're talking about context object John. But because of line number 4, they are different. Right? So if you think about 2 versus 6, also not the same. Because number 4. This kind of pattern here will occur over and over throughout the course. But I want to point it out right away. You just want to remember, whenever you want to really analyze what's the effects for a particular method call, the best way to really decipher that is tracing. All right, that's something I'll also go over with you in detail. Okay, 5 minutes. Okay, I think we should be able to do a little bit of data types. Okay, I'll do the eclipse next time. Okay. So I think let's just see this. Just bear with me. So these stuff you guys can definitely go over, right? They are pretty straightforward, but please do so. I want to, okay, directly here. So now we're talking about slide number 14. Okay, 14, data types. I will cover a little bit of data types. So what's really a type? So there are two types in Java, either primitive or reference type. You can think about this one-line definition is so important. Whenever you say a type, it's simply like a set. For those of you who took maybe 1019, like a logic course, you know what set is, right? It's a collection. So whenever you declare a type, you simply signal there's certain collection of values a variable can store at the runtime. What do I mean? Okay, let's take a look. Let's just cover a little bit, and then we'll continue from Wednesday. That's 3 minutes. Okay. So in Java, each variable must be declared with a type. Okay, this is so important. It's a principle, right? If you somehow put a variable that has not been declared before without a type, it's going to be compilation error. Okay. So, for example, you might say integer I over here. What does that mean? So think about, so this one here is I, it's a variable name. And this integer here to the left-hand side is called a declare type. For I. And integer here, it's a particular category called primitive type. Okay, primitive type. You will see primitive actually in the slides, right? So I just put an acronym here, primitive type. So now what does that really mean for this declaration? Okay, this means at a runtime, I can store any value that's a member of int. I'm trying to write in a way that sounds a little bit more mathematical, right? We talk about set and member, right? So if you think about integer being a set, it's basically, for example, it's basically a set that's very big, right? At some point, you may get -2, -1, 0, and 1, and 2, and 3, etc., right? There's certain minimum and there's certain maximum, right? So we don't need to know the exact value, but it's more like a set. When I say I is declared to be of type integer, I'm saying that at a runtime, I can only store values that's drawn from this particular set. So for example, would 23.4 be a member of this set? Not really, so it wouldn't compile. Would 23 over here, in quote, a member in here? Also no, right? It's got to be exactly a member from there you can store in the variable. All right? One more thing to mention, give me 1 minute, and then we'll continue, okay? We'll talk about another category called reference type that's going to take us more attention, which I'll do. But I want to just say for your knowledge. So for programming languages like Java, they force you to declare a type for each variable. So this is so-called static type programming language. Static type programming language. Static in the sense that at the compilation time, at the compile time, you have to declare the type for the variable. If there's any inconsistent use of the declared type, there's going to be compilation error. On the other hand, there are certain languages that are called dynamic type. For those of you who took 1015, Python is that category. All right. So dynamic, just bear with me, 20 seconds. I do appreciate your patience. Dynamic type programming language. For example, Python. All right, so again, please make sure you complete lab 0 part 1 in time. Wednesday, I'll do a demo in the lab. I'll tell you which session I will go, and then I'll see you on Wednesday. Take care.